All right, this is just a very short video on perfect square trinomials because they're not covered in my lecture. You can solve them the way that we solve any trinomials when we're changing them back to binomials, but you can alternately just learn a bit more about them specifically and why a perfect square trinomial looks the way that it does. So a trinomial has three terms, as we know. Perfect square means that a number is obtained by multiplying a number by itself. So if we say 3 times 3, we get 9. So we call 9 a perfect square. A perfect square trinomial is going to be a trinomial that is the answer to the multiplication problem of one binomial squared, or one binomial times itself. So x squared plus 4 is the same as, or sorry, x plus 4 squared is the same as x plus 4 times x plus 4. And when we multiply that out, when we FOIL it out, what we get is x times x is x squared. X times 4 is 4x. These two are also 4x. And then 4 times 4 is 16. If you combine the 4x and the 4x, you get x squared plus 16x. You don't get 16x, you get 8x plus 16, getting ahead of myself. So x squared plus 8x plus 16 is a perfect square trinomial. Good? So it can be the x squared plus 8x plus 16 can be decomposed, we call it, into two binomials, a binomial times itself, right? And then when we multiply those binomials back together, we get the perfect square trinomial. Let's look at basically the formula for the perfect square, or the pattern, I think would be a better way to say it. The pattern for the perfect square trinomial. Here is your binomial. I'm going to name a binomial only has two terms, right? X and 4. So I'm going to call it A and B. There are two. You can either have A plus B or A minus B. But remember, it is being multiplied by itself. So we have a squared symbol right there. Okay, so this is the binomial. And then that binomial becomes a trinomial. This is the minus, so now we're going to subtract the 2ab, but we're still going to add the second term. Okay, so that's the pattern. The first, so if we're looking at the binomial, we have a as the first term and b as the second term of the binomial. In the trinomial, the first term is the square of this number, right? The third term is the square of the second number. The middle term, this is twice, right? Twice the product, because we are multiplying by 2 and multiplying them together. Twice the product of the two terms of the binomial, a and b. Okay. And if this is, I'm sorry, we're mostly looking at the trinomial and decomposing it into the binomial. So if your trinomial has a minus here, then your binomial is going to have a minus. If your trinomial has all pluses, then your binomial will have a plus sign, okay? All right, if we have something like the number x squared minus, let's stick with plus 10x plus 25. All right, I'm going to look at this. I'm going to say this looks more like this pattern. Sorry, I labeled that's binomial. This is trinomial. So my pattern here is that this looks like a squared plus 2ab plus b squared. What I need to do now is check. So here my a is going to be the square root of x squared, right? So that's going to be x because remember, this is already squared. So if I take away the squared, a equals x. B is the square root of 25. The square root of 25 is 5, right? A is x, b is 5. Those are all our variables. So is it true that x squared plus 2 times x times 5 plus, 5 squared will give me that? Because here's my a squared, here's my 2 times a times b, and here's my b squared. X squared plus 2 times 5 is 10. 5 squared is 25. So what you want to do when you see that x squared is a perfect square and that 25 is a perfect square is you want to look and say, is 10x the same as 2 times x times 5? Find my a, find my b, see if this is 2 times a times b. All right, so I'll just do 3 very brief examples. Here is 9x squared minus 6x plus 1. So I want to know, is this a perfect square trinomial? I have a is going to be 3x, right? Because 3x times 3x is going to be 9x squared. So 9x squared is a perfect square. B is going to be 1 because 1 times 1 is 1. So that's okay. So I have a, and it's a minus. So this, I'm going to use this trinomial formula. A squared minus 2 times a times b plus b squared. A squared is 3x squared minus 2 times 3x times 1 plus 1 squared. 3 squared is 9, x squared is x squared. Negative 2 times 3 times 1 is negative 6 with 1x, and then 1 squared is 1. So, yes, this is a perfect square trinomial. We made sure that this is a squared, this is b squared, and that this is 2 times a times b. So, our perfect binomial answer to 9x squared minus 6x plus 1, we said that a is 3x and b is 1. That means I have 3x minus 1. This is a squared. This is minus 2ab. This is plus b squared. And this is a minus b. Sorry, I forgot the squared. Good. When a is 3x, b is 1. I'll do another one. All right, another one is maybe 4x squared plus 8x plus 4. Good. So in this case, I'm going to use this model of the trinomial. A squared plus 2ab plus b squared. A is 2x, right? B is just the number 2 because the square root of 4x squared is 2x. The square root of 4 is 2. So that means I have 2x squared plus 2 times 2x times 2 plus 2 squared. 2x squared is 4x squared plus 2 times 2 is 4 plus times 2 is 8 with 1x, and then 2 squared is 4. So it does go back to the original trinomial. That means that 4x squared plus 8x plus 4 is the same as a plus b, right? Because this is A squared plus 2AB plus B squared equals A plus B. I always forget that squared. Good. All right, so those are perfect square trinomials.